Welcome back, everybody. I hope you're doing well. And just about to the end of the fourth quarter here, so just a couple more weeks, and hope everything's going well with your classes and everything else. So what we're going to get back into today, as we finish off a unit here on some things in an XY coordinate plane. Two important formulas we've learned about the last few weeks, which are the distance formula and the midpoint formula. Now what we're going to go back to is an application of the distance formula. So this goes back to a few weeks ago. The last 2 weeks we spent on the midpoint formula. So we're going to see an application that involves right triangles. So to prepare you a little bit for some things that you'll see in geometry next year, actually. So as you remember, I'm sure, from past classes, very likely in junior high, the Pythagorean theorem is this. It's a squared plus b squared plus equals c squared. And the a, b, and c represent side lengths of a right triangle. And if this is true, if I square and add the two shorter side lengths, and the sum of that equals the square of the longest side, which, if you remember, is called the hypotenuse, that means we have a right triangle. Hypotenuse is always the longest side of a right triangle, so it's the one that's on the side on its own in Pythagorean theorem. So again, if the side lengths, when I square the two shorter ones and add them, and that ends up being the same value as the longest squared side, I know that those three side lengths have to make up a right triangle. So using that concept, we're going to be able to determine whether or not three given side lengths represent what would form a right triangle or not. So jot this down, the example and the directions here for them. So determine whether or not the side lengths would form a right triangle. Okay. So number one here. So if I have a side length, maybe these are inches, centimeters, I'm not sure units, but these represent the three side lengths of a triangle, 6, 10, and 8. Now, the first thing to identify, and I always start here, this is pretty easy. Identify which one is the longest side. That has to be your C. So what I'm doing is I'm using these three side lengths and going to fill them into Pythagorean theorem accordingly. So the longest side must always be on its own squared, okay, in order for this to tell you the result you need it to. 6 and 8, does not matter which one I call A or B, because they're going to be on the same side of the equal sign anyway. Maybe I'll call A6 and B8. All right, so now I simply fill these in. And again, all I'm checking is to see whether or not we get a true statement at the end out of Pythagorean theorem. And that will tell us if we have a right triangle. So A squared becomes 6 squared plus B squared is 8 squared equal to C squared, which is 10 squared. Now all I do is I just evaluate this. 6 squared is 36, 8 squared is 64, 10 squared is 100. And sure enough, if I add 36 and 64, I do get 100. So, because Pythagorean theorem resulted in a true statement by filling in these side lengths, our conclusion is that these side lengths do form, we'll say these lengths form a right triangle. Okay. And that's it. It's a simple check with the three side lengths of whether or not Pythagorean theorem holds or not. Moving on, number 2. See if you can try the same thing. I'd recommend go ahead and pause. See if you get the same result I do after I fill it in. Number 2 here. So again, identify the longest side. It's going to be 8 between 5, 7, and 8. And once again, all I'm going to do, plug in my two shorter sides, 5 squared plus 7 squared, and set that equal to 8 squared. Evaluate just like we did in number 1. 5 squared is 25, 7 squared is 49, 8 squared is 64. If we add these two together, 25 plus 49 gives us 74, which very clearly is not equal to 64. So, for this one, our conclusion is that these lengths do not form a right triangle. So, does not form a right triangle. All right, last one, number 3. So I'll start with this one. This is kind of a one where we have to do a little legwork at the beginning. You know, not terribly difficult. But the problem here is that, well, the first step was always identify the longest side. And don't be tempted just because you see the number 65 to say that that is the longest side. All right, so if this is in a radical form, now we're going to have to plug in the square root of 65 in exactly as is eventually. But right now, let's get a decimal approximation for this, because I don't know which is the longest side. I obviously know it's not 4. Because 9 is bigger than 4. But between 9 and square root of 65, I have to determine which one of those is the larger of the two sides to go on the equal side on one side on its own. So if I were to type the square root of 65, and I just do this off to the side, type that into your calculator and hit equals, and get a decimal approximation. Now, if you think perfect squares, it's very close to 64, which has a square root of 8. So what I know, and I didn't even type this in, but I know that this is going to be maybe approximately 8.1. Check me and see if I'm right on that, or very close anyway. So now that I know that 8.1 is clearly less than 9, I know that 9 must be my hypotenuse, or my C, when I plug into the Pythagorean theorem. So once again, I do 4 squared plus square root of 65 squared equal to 9 squared. Now, yeah, I know maybe you're thinking the radical looks pretty ugly, but you're going to like what happens on the next step. Square everything. 4 squared is 16, but watch how nice this is. If you remember, a square and a square root are inverses of one another. So they simply cancel each other out anytime that occurs, and you're just left with 65. 9 squared on the other side is 81. And there you go. Now we have a problem just like the last ones. 16 plus 65 is 81. And sure enough, we do have a true Pythagorean theorem once again. So once again, our conclusion, as in number 1, these lengths would form a right triangle. All right, so again, there's the application of the distance formula. As usual, there will be a short assignment to go along with this. Please get that to me as soon as possible, and see me with any questions. Have a great day.